Right. So far we have looked at um, the different ways in which we can preserve push the left lifting property. So we have seen that transfinite compositions, coproducts, pushouts, and compositions in general all preserve the left lifting property, right? So what we're going to do is we're going to combine these things into one small lemma that will essentially give us the first part of the small object argument, um, and we'll see how. What this lemma says is that given any morphism and any ordinal, we have a lambda sequence sorry and a natural transformation from ZF to Y, which is the constant lambda sequence. Every arrow is the identity arrow, every object is mapped to the object Y, such that the first element in the sequence is X, the first arrow, right? So the natural transformation essentially gives you a collection of beta, rho f betas, right? So each rho f beta is going to be from ZF beta to Y, and this is going to be F, and we get the transfinite composition, which we call gamma F, of this lambda sequence, which will be an arrow from X, which is ZF naught, to ZF lambda once it's defined, has LLP with respect to I write perp. Now, how do we generate this lambda sequence? So essentially, to describe the lambda sequence, we need to know what ZF beta is in two cases, where beta is a successor and where beta is a limit ordinal. So, and similarly for rho f, right? So what we do is first we look at the case where it's a successor. Suppose we know set beta f and rho beta f, then we consider all commutative squares. So S to be set of all commutative squares such that you have A to B a map in I, and you have something this one, where this is beta, right? And then you take the coproduct of this over the entire set, and you say that the push out of this coproduct is ZF beta plus 1, and the cocone that you get since this is a coproduct, the cocone formed by Y under this diagram induces an arrow from ZF beta plus 1, which is unique, and this triangle commutes, preserving the naturality of rho f beta plus 1, and hence we have what we want. For a limit ordinal, well, for a limit ordinal we simply take the colimit, and define this as def gamma. So let's say gamma is the limit ordinal. We take the colimit, and since y and rho beta f beta less than gamma will form a cocone, by assumption implies we can define rho gamma f as induced morphism from Z gamma f to y, and hence we are done. And we see that since this is a transfinite composition, so the transfinite composition defined by this lambda sequence there is also a map rho f lambda, and we have rho f naught. This triangle commutes because of rho f is natural, and gamma f is transfinite composition of pushouts of coproducts of maps in I, which implies gamma f preserves I's left lifting property. So you have this right.